In this video we're going to look at the power rule, and we're going to use the power rule to expand logarithmic expressions. And this is the power rule for logarithms. It basically states that if m and b are positive real numbers and b is not equal to 1, and let r be any real number, that the log base b of m to the r is equal to r times the log base b of m. So the proof is in a separate video, and just as before, I encourage you to look at the proof so that you can understand why you're allowed to use this property. This video is really intended on showing you how to use the property, but just on a kind of a related property or rule is the power rule for exponents. When you take x to the m and raise it to the n, it's equal to x to the m times n. And so when you take a power and raise it to a power, you multiply the exponents. And so in a loose kind of related way, basically a log is a power, and you're raising m to a power, and in the end you're taking r and multiplying it by a log, which is a power, an exponent. But let's use this property to evaluate, or expand these expressions. So we'll write the rule base b of m to the r. That's a little wide. That's equal to r times the log base b of m. And so for this expression right here, the 5 is going to come down in front as a factor. 5 times the log of 8 base 6. So generally when you're asked to expand a logarithmic expression, you take any exponents and rewrite them as powers. And so for the next one, for b, before we use the power rule, we want to rewrite the square root of 10 to 10 to the 1/2, and then we'll multiply the log of 10 times the half. And we know that the log of 10 is equal to 1, so if we just multiply a half times 1, we'll get 1/2. And the last one, I'm going to show you two different ways to do this one. One is to use the power rule first and then simplify, and then the other would be we'd expand a little bit. We'd raise that expression to the power of 3 first and then use the power rule. So let's first use the power rule. We'll bring the 3 down as a factor first. Now I'm multiplying 3 times the log of a product, and the log of a product is the sum of the logs. Now the log of 7a is the log of 7 plus the log of a, and since I'm multiplying the log of a product, I now have to multiply a sum, and without the parentheses here, I'm really just multiplying the log of 7 by 3, when in fact I need to multiply the whole sum by 3. Then we'll distribute the 3, and this is considered expanded. Your second option on this problem would be to raise the 7 and the a to the exponent first. So we'd have 7 cubed, a cubed, then expand. So now I've got the log of 7 cubed, a cubed. When you take a product and raise it to a power, each of those factors gets the exponent. I'm going to get the log of 7 cubed plus the log of a cubed. The 3 comes down. 3 log of 7 plus 3 log a. Just a word of caution. The power rule, log of x base b to the r, x to the r, is not the same as saying the whole logarithm raised to the r power. So you've got to be careful there. It does not mean the same thing. So the question is, what's the big deal about this rule? Why would it even benefit us at all? So if you think about if you're working on a problem like this without a calculator and you wanted to evaluate this, well, 8 cubed, if you multiply that out, you get 512. So I've got the log base 2 of 512, And if I want to evaluate that, I'd say, well, let's let that equal x. And then I'd say 2 to the x is equal to 512. And then literally I could play around with trial and error. I mean, without a calculator, this would be a bear. I'd have to keep multiplying 2 a number of times until I got to 512. And the answer is 9, right? If I multiply 2 by itself 9 times, I will get 512. But if we use the power rule, and obviously these properties and rules were developed at a time when we didn't have calculators, so this made a huge difference in evaluating. If I bring that 3 down, I have 3 times the log of 8 base 2, and I know I can evaluate the log of 8 base 2 pretty quickly. It's 2 to what power gives me 8? That's going to be 3. So 3 times 3 equals 9. So here's an example where the power rule is extremely helpful in evaluating. It's also helpful in calculus if you can rewrite an expression rather than have it in exponential form, to be able to write it as a product. So what I'd like you to do next is pause the video, and I'd like you to expand some more logarithmic expressions, and some of those we're including the power rule in there. Alright, so the first one, we just want to expand. We're not asking to evaluate. Just want to expand the expression. So the 4 comes down as a factor, and it's the log base 5 of 10. The next one, before I expand it, I'm going to write the y to the 1/3, and now the 1/3 comes down as a factor, and it's 1/3 times the log of y. Here we have the argument is being raised to the second power. Remember, that's not the same thing as the natural log of 3x minus 5 raised to the second power. In this case, we wouldn't be able to use the power rule, but here we can. It's 2 times the natural log of 3x minus 5. And since we're not allowed to expand a sum or a difference, then this is as far as you can go with this. This is expanded.